Welcome to this section on relation and function. This section's lesson plan are: what is relation, domain and range of relation, the different ways of expressing relations, and the relationship between relation and functions. First, let's dive into the definition of relation. Relation is a set of order pairs, or relation is a set of pairs of input and output values. From this definition, we can understand that there is a set formed by order pairs, and those order pairs represent the input and output values of the given relation. It's customary to learn and operate mathematical definitions in the form of mathematical notations. So let's convert this definition into mathematical notation. The symbol of relation is R equal to. In the definition, we have the word set. So let's add the symbol of set. This brace or symbol of set is used to express any kind of sets. What makes relation different from other sets is it's a set of order pairs. Hence, let's add parentheses and comma in which the input and output values will be listed. This mathematical notation and the definition refer the same concept. In this mathematical notation, we use only 4 order pairs as an example, but in actual scenario, the number of order pairs may be less than or greater than 4. Let's add numbers to these order pairs in a manner that help us to explain the next concepts. 1, 3 in the first order pair, 2, 6 in the second order pair, 3, 9 in the third order pair, and 4, 12 in the fourth order pair. These order pairs can be represented by the order pair x, y, where x stands for the input values and y stands for the output values. Input values or values in place of x are called domain of the relation. Output values or values in place of y are called the range of relation, meaning domain is a set consisting all input values of the given relation, and range is a set containing all the output values of the given relation. To make these two concepts clear, let's find the domain and range of the given relation. Domain of relation equal to, since domain is a set of input values, we have to add the symbol of set and list out all the input values or the first values of each order pair, usually in ascending orders. For the first order pair, the first value or the value in place of x is 1. For the second order pair, the value in place of x is 2. For the third order pair, the value in place of x is 3. And for the ultimate order pair, the value in place of x is 4. Thus, domain is a set consisting these 4 input values. Range of relation equal to, range refers a set consisting output or second values of each order pair. Second values are simply values after the comma or values in place of y. These are 3, 6, 9, and 12. The topic of our discussion is relation and function. We are learning these topics together because they have something in common. Both relation and function refers a set of order pairs, but there is an aspect that makes function different from relations. Function is a special type of relation in which each input has only one output. For a relation to be considered as a function, no first value in a given relation has to be mentioned more than once. In the given relation, each domain or input value is mentioned only once. Thus, this relation represents a function. Relations may not always be expressed in the form of order pairs, with a number of ways for expressing relations. Let's see some of them. As we have given above, relations usually expressed as a set of order pairs. Second, relations can be expressed by using mapping diagrams. It's a diagram that maps or shows the correspondence between domain and range of the given relation. To represent the given set of order pairs by mapping diagram, let's write domain or x value as the left and range or y value as the right. Let's draw an oval shape under each of domain and range and then list out the elements in ascending order from top to down. X values are 1, 2, 3, and 4. Range or y values are 3, 6, 9, and 12. Next, we have to show the relation between domain and range by drawing an arrow from domain to range. 1 corresponds to 3, 2 corresponds to 6, 3 corresponds to 9, and 4 corresponds to 12. To determine if this relation is function, we have to analyze the arrow drawn from domain to range. If each value in the domain points to a single value in the range, that relation is function, otherwise it's not. In this diagram, for every input value, there is only one output value. Therefore, this relation is a function. Relations can also be expressed by using tables. To represent these four order pairs in the form of table, what we are going to do is just to draw a table with 2 rows and 5 columns, and then fill the values of x and y in a manner that can show their correspondence. Let's fill x values first. 1, 2, 3, and 4. 1 corresponds to 3, 2 corresponds to 6, 3 corresponds to 9, and 4 corresponds to 12. This tabular data can also be represented by using XY plane. Thus, the other means of expressing relations is by drawing graphs. To do so, let's draw x-axis and then y-axis. All the 4 x values are positive, and the difference between consecutive values is equal. So, let's divide the positive side of the x-axis into 4 equal parts and put a mark on each spot. Likewise, all 4 y values are positive, and the difference between consecutive values is equal. Again, let's divide positive side of y-axis into 4 equal parts and put a mark on each spot. Finally, let's locate x and y values on the marked spots. To point 1, 3, let's draw a straight line from 1 to up and from 3 to the right. The point where these two straight lines intersect is an order pair 1, 3. Red colored dotted lines are not part of this graph. Rather, we use them just to determine the point of intersection. Thus, we have to remove them. Following the same pattern, we can indicate other order pairs as 2, 6, 3, 9, and 4, 12. For a relation presented in the form of graph, the best way to determine if that graph represents a function is to use a vertical line test. Vertical line test says, anywhere we draw a vertical line, that vertical line shouldn't touch the graph at more than one point. Meaning, if the vertical line touches the graph only at one point, that graph represents a function. If the vertical line touches the graph at more than one point, that graph doesn't represent a function. Let's do that test for this graph. Anywhere we draw a vertical line, it touches only one order pair. No vertical line can touch 2 order pairs at a time. Hence, this graph represents a function. The other method for expressing relation is by using mathematical equation. In the given relation, x values are natural numbers from 1 up to 4, and y values are the first 4 multiples of number 3. In each order pair, if we multiply the input value by 3, it gives us the output value. 1 times 3 is 3, 2 times 3 is 6, 3 times 3 is 9, 3 times 4 is 12, meaning y values are 3 times x values. So the relationship between x and y values can be expressed as y equal to 3 times x, where x equal to 1, 2, 3, and 4. This mathematical equation can also be expressed as word problem. That's y is 3 times x, where x is the first four natural numbers. If we are given with two sets and asked to form a relation from one set to another, we can formulate that relation in the form of order pairs. Let's see this definition first. Given two sets A and B, any set R of order pair X, Y, where X element of A and Y element of B is called a relation from A to B or A cross B. And for order pair X, Y element of R, X is the first component or coordinate and Y is the second component or coordinate of order pair X, Y. Let's illustrate on this definition by using example. Let A equal to the set consisting A, B, and C, and B equal to a set consisting 1, 2, and 3. List all the elements of a relation from A to B and B to A. Find the domain and range of each relation. Determine if each relation represents a function. First, let's form a relation from A to B. In forming this relation, what we are going to do is we will take one element from the first set, that is set A, and then associate it with each element in set B. A cross B equal to, let's form the symbol of set. The first element of set A is small letter A. We have to form an order pair by relating A to each of elements in set B. That's A relates to 1, A relates to 2, and A relates to 3. Likewise, B has to relate with each order pair in set B. B relates to 1, B relates to 2, and B relates to 3. Finally, C has to relate to each order pair in set B. C relates to 1, C relates to 2, and C relates to 3. Hence, it's apparent that we form a set of order pairs by forming a relation from A to B. Now, please pause the video and reply the next questions by yourself. That's find the domain and range of this relation and determine if it represents a function. Let's check the answers. Domain of relation equal to, domain is a set of input values. Hence, we have to list out all the input values. In the first three order pairs, the value in place of x is A. In the next three order pairs, the value in place of x is B. And in the last three order pairs, the value in place of x is C. Here, we can see that the domain of this relation is the same as set A. Range of relation equal to, range is a set of output values. Hence, we have to list out all the output values. In the first order pair, the value in place of y is 1. In the second order pair, the value in place of y is 2. And in the third order pair, the value in place of x is 3. For the remaining order pairs, the second value or the value in place of y is simply a repetition of either of these three elements. Thus, the range is the set containing these three elements. Here, we can see that the range of the relation is the same as set B. Whenever we form a relation from A to B, domain of the resulted relation is set A, while range of the relation is set B. That's always true. To check this relation represents function or not, we have to analyze the first element of each order pair. If a given element appears as the first element of two or more order pairs, that relation doesn't represent a function. In this relation, each of the first elements appear 3 times. Thus, this relation doesn't represent a function, or this relation is not a function. Again, feel free to stop this video and form a relation from B to A by yourself and answer the questions. Good. Let's check the answer. B to A equal to, in this case, we will take one element from B and form an order pair by relating it with each element in set A. One relates to A, one relates to B, one relates to C. Similarly, we can form the other order pairs as 2, A, 2, B, 2, C, 3, A, 3, B, and 3, C. Domain of relation equal to set B because we form the relation from B to A, and range of relation equal to set A. Each of the x values in the order pairs are repeated 3 times, so this relation doesn't represent a function, or this relation is not a function. I hope you understand all the explanation. In the next video, we will solve some fascinating questions on relation and function. That's all for this part. Bye bye.